This week, Vicarious' very own Roy Cohen and Shani Dodge join us to kick off the show with a technical segment titled Generating Threat Insights Using Data Science. Next up, Harry Sverdlov from Zscaler joins us for a technical segment on securing the enterprise software supply chain. I wonder where we got that topic from. In the security news, how suspected Russian hackers outed their massive cyber attack, where we'll talk about SolarWinds. And if we get a chance not to talk about SolarWinds, millions of unpatched IoT and OT devices threaten critical infrastructure. Zodiac Killer's cipher has been solved, and a security researcher states SolarWinds 123 password left the firm vulnerable in 2019. More SolarWinds. Why the weakest links matter, and a 26-year-old turns a mistake into being added to honors geometry class to becoming a rocket scientist. All that and more on this episode of Paul's Security Weekly. This is Security Weekly, for security professionals, by security professionals. Broadcasting live from G-Unit Studios in Rhode Island, it's the show where exploits run wild, packets aren't the only things getting sniffed, and the cocktails flow steady. It's Paul's Security Weekly. Sophisticated attackers are targeting credentials to escalate privileges. Ativo Networks provides an innovative solution that finds, cleans, and monitors exposed credentials to reduce attack surfaces. Additionally, the solution alerts when attackers try accessing Active Directory objects while hiding data and derailing them with disinformation. Organizations can go one step further and hide real credentials among deceptive lures that lead attackers to decoys for recording TTPs and forensic evidence. Find out more at securityweekly.com/Ativo Networks and sign up for a free trial. NetSparker, the developers of a comprehensive automated web security platform that includes web vulnerability scanning, assessment, and management. NetSparker's desktop and cloud-based security solutions employ a unique and dead-accurate vulnerability scanning engine that automatically verifies vulnerabilities and provides a proof of concept. For more information, visit them on the web at securityweekly.com/NetSparker. Want to be more thorough while also working faster? It doesn't matter if you're on the red or blue team, an augmented reality overlay can enable you to be more thorough and faster at the same time. No glasses, no goggles. Polarity delivers this superpower as an overlay on top of your existing workflow and tools. The free Community Edition connects to the data you care about to overlay the context you need to make informed decisions. Apply for early access today at securityweekly.com/polarity.
And welcome to the show. But first, let me introduce you to a man whose jacket outside is frightful, and throwing it on the fire would be delightful. Mr. Paul Asadorian!
Welcome, everyone, to Security Weekly. This is episode number 678, recorded December 17th, 2020, right here in G-Unit Studios in Rhode Island. Thanks, Larry. You like my jacket, huh? Mr. Larry Pesce is here.
It really is.
Virtually here. Thank you. There's pants to go with it, but I didn't bother because no one sees the pants. I didn't bother wearing the matching pants. Never mind. Mr. Lee Neely is here with us. Lee, welcome. And Lee is on mute. It looked like a great introduction, though, didn't it? Well, let's try that again. And Mr. Lee Neely is here with us.
Hey there, here I am with my long sleeve Hawaiian shirt. This time I'm not on mute and ready to party.
It looks like a pajama top.
It does. It does look like pajamas. Shh. Mr. Jeff Mann is here with us now that he spoiled that. He's here. Hey, Jeff.
Surprise, I'm here.
Hanging in there with us tonight also Mr. Tyler Robinson. He's got an apparatus. We're just going to try and keep his brain off of whatever kind of pain you might be in, my friend.
Appreciate it. Small apparatus.
Yes. For those not viewing the video, it's quite a large apparatus. Do you always...
It's just, without context, you might give them a little bit...
Now so many people are going to go watch the video. No, Tyler. Do you always end up missing our live streams? Need somewhere to flag Security Weekly podcast that you want to listen to? Subscribe on your favorite podcast catcher or our YouTube channel. Sign up for our mailing list and join our Discord server and stay in the loop. All things Security Weekly. Visit securityweekly.com/subscribe. This segment is sponsored by Vicarious. To learn more, please visit securityweekly.com/Vicarious. Joining us today from Vicarious are two now friends of the show because they've been on so many times. We love having them, Roy Cohen and Shani Dodge. Welcome back.
Thanks, Paul. Thanks for having us.
Hi, good to be here again.
Nice to have you both. We're going to be talking about generating threat insights using data science. I'm excited. I want to learn more about the data science that helps most with vulnerability prioritization. You may know a thing or two about that, I'm told.
Yeah, it's a super interesting topic, given the fact that there are so many data points today that companies need to consider, right? There are so many feeds. I think you read in the news day in and day out about new incidents, which resulted by, some of them at least, by software vulnerabilities and issues like that. And it's very hard to expect one in a given company to really try to understand what they should do. Because of the fact there is the inflation of data. And just a recap in the previous sessions where we discussed a bit about how we predict vulnerabilities, how we can also protect them in the memory, and a couple of sessions about prioritization. But looking beyond the horizon, there is like this need that there will be so many data points where a company needs to really having something to focus on the most critical threats. And we need to create, maybe rely on existing frameworks, like we'll be discussing a bit about the MITRE framework, and how we can facilitate algorithms in order to really help us to better focus on the things that matter. So this is kind of what we wanted to discuss for today.
Yeah, it's really awesome. We were talking about this today. That combination of supervised and unsupervised learning was kind of the lesson that I was getting today, that you can have users tag content, but also based on behavior and other factors, you can automatically tag that content. It sounds like you're doing something similar inside the product today.
Yeah, definitely. And when it comes to tagging, eventually it should also be consistent of something that a company can relate to. So I want to start by showing. I think we should all be quite familiar with that, with MITRE's attack framework. Obviously, it goes through the different steps of the attack, from the reconnaissance up until the impact. And the two, let's call it the mitigation, which can also are connected tightly to the techniques, are things that we kind of discussed about. And the patches protection obviously is something that in terms of mitigation relates to exploit protection. And there are different techniques that it basically covers. And of course, the patching that we also are covering covers some other techniques. And eventually, when you have again, the inflation of data, you need to, and you want to have standards which you're going to rely on. The MITRE attack framework is one thing that we can really look up to. And there is a case study we want to share. We have this customer, which is a huge enterprise. And when we started the discussion with, basically he told us he got two scanners inside his network, two vulnerability scanners, and multiple feeds of data, threat intelligence and darknet analysis, and the CERT, which basically feeds them with the threats. And we asked him, how are you basically processing this, this huge amount of data points in order to make a decision? He says, I really cannot. It's really hard. It's a very specific task. And he kind of also showed us that he tries to correlate things back to the techniques in MITRE. And this is why we wanted to go through this today. And Shani will be elaborating a bit more about the different data points and data sets that would be used for the models and for the algorithms. So over to you, Shani.
Thank you, Roy. So, I really relate to the example you just mentioned, because I deeply believe that the biggest challenge in the 2020s is not collecting data, but processing it and turning it into knowledge and insights. And I'll just share my screen with you. And I made kind of a really simple example of a organization's data, right? So here is, of course, really little and not, and of course in an organization it's much bigger, much more information. But here we have around. Well,
also, I think in the real world, Shani, there's a lot more criticals and highs than maybe you have listed there.
Of course, of course. Here there's just only 4 servers, 4 desktops, around, I guess, 10 applications, maybe 20 vulnerabilities. That's really not the real world. But if we're looking at that and we're asking ourselves, how can we analyze all this information? And these are, 50 rows only. So we can try manually, but it seems quite hard to me. And we might try, basic statistics or kind of predefined rules, but it feels outdated. So, Paul, what do you think would be a better way to analyze this information?
I think my vote would be with machine learning.
Yeah. So I really relate to what you say, and I think that applying machine learning algorithms is like the future. And there's different algorithms and different methods, but we'll be speaking a bit about the machine learning. And
yeah,
before
and I think
we start,
I think machine learning gets a bad rep because there are people who claim that they do machine learning, but it's really not machine learning. Like just basic matching is not machine learning. And then it seems to me the ones that actually do machine learning in some capacity, as you're about to describe, Shani, don't kind of like tout that as their like primary feature, for example. So I think you fit that mold very well, and that this is all last segment of the year you've done several, and now we're talking about machine learning, which has always kind of been there in the background.
Right. So, but just a moment before we start to discuss how can we apply machine learning and create a customized threat identification process or model, let's just define, what is exactly machine learning. So actually, it's a task of training a function that maps an input to an output. And there are different types. One is the supervised learning. This refers to learning that is based on labeled data, meaning input and output pairs. An example of using this supervised learning would be to solve a classification problem. And, I hope you're all familiar with the Google Photos app, because they have really cool features. And I want to show you one of them. The one that recognizes things such as food, sky, cars. So this is a really good example of classifying using a supervised learning. And why is that? Because the programmers in Google sat down and took some photos of cars and labeled them as cars, and then photos of sky and labeled them as sky, and trained a model. And now when that model runs on our app, it goes over all the photos, and when it sees car, it groups it into cars, and so on and so on.
Yeah, Shani, I find it's about 80% correct in Google Photos. But is a shining example of machine learning. I think Moxie, Mahler, and Spike gave the analogy of you showed a bunch of pictures of cats. Now the application can recognize cats. When you show random pictures, it'll tell you which ones are cats and which ones are not.
Right. And if we'll keep on, so there's another type of unsupervised learning, right, where we detect patterns in dataset that aren't labeled. And a good usage of this unsupervised learning would be solving a clustering problem. For example, if we'll keep with the Google Photos example, grouping people, right? So it's kind of a face recognition where the Google programmers do not know, or the data where the function is trained on doesn't have these people, but when it runs on our system, right, it looks through our photos and groups in by faces. So every time we press on a face, we can see all the photos that this person appeared in.
Yeah,
so
and then it asks you, right? It gives you 2 pictures, and it's like, is this XYZ person? Yes, no, or maybe. And like sometimes I don't know. I'm like because it's a picture of an adult and the child version of that person, and you're like, I don't know if that's the same person, but it collects. The point is, it collects data from the user.
Exactly. So today, my Google app just notified me and asked me about 2 people, 2 faces. Actually, it's the same person, my father-in-law, and he asked me, is that the same person? And one was just straightforward, and one was from the side looking. And it's really interesting how the model that it found some high similarity, but it wasn't sure it's the same, so could iteratively retrain itself, right? When I said, yeah, merge these groups. So this is really good example. So going back to our machine learning, so after we discussed a bit what is it, we can now apply a machine learning algorithm to identify threats in our organization, right? And let's put in mind that the desired output is a function that maps new data from our organization, unseen input, right, to a MITRE threat, the group of threats that Roy just demonstrated. And let's ask ourselves, what are the steps for that? So the first would be to collect data, right? Then we would like to turn this data into an input for our model, meaning to pre-process it into features. Features are the input variables of our model, and select those that we would like to train our model with. And of course, at the end, to train and evaluate our model. This is an iterative process. And just before we start speaking about what data sources can we collect, I feel that it's really important to mention that the most important stage of a good model training is the data that is collected and the pre-processing of it. And therefore, it's really important to put time and effort into it, because the accuracy of a model is based on the training data. So Paul, what data should we collect in order to identify threats? What do you think?
Certainly not garbage, because garbage in, garbage out, I believe, is the analogy an analogy to describe what you were just talking about. But the data that we want to input is that spreadsheet, right, that you showed earlier, and import those fields. Yeah,
but I have another idea. Let's see what you think. What about like kind of vendors' market share? Do you think it impact the threat, right?
Oh, I'm gonna go with the CVE.
Yeah, CVE is just something similar, right? We can think about how to add some information that are not just cyber related, but could really impact our model, right? I'll give you some example. For example, what do you think about exploits of older versions of the same application that have some input about future threats?
Right. The age of the vulnerability, for example.
Right.
So there are things that there are the things that we all know. Again, the age of the vulnerability, the CV, the description, the things of the exploit DB. But if I would introduce you to two applications, and we're not mentioning the vendors, but you have like a bigger vendor which we all know that are frequently being hacked, and we are every Tuesday need to spend time around. And you have some vendor which is a bit less known. So because you as a human being, you know that this one vendor is far more known than other, you can make this assumption. But when you introduce this data point to a machine, you need to find like pseudo algorithms which can generate the same result. So one idea or one feature you can introduce to a model in potential is market share. Or for instance, It could be crazy, but Twitter followers. So you're going to inspect the followers for a given company, or even the YouTube likes for a given company. And these things in potential could be introduced to a model to predict whether something will become a threat, aside of the CVEs. So when you become, you have a lot of data points, a lot of pieces of information, this is where a model is required.
Roy, your answer was way better than mine. Thank you.
So look, I had a question, Roy. Is it market share or install base?
So some of the things eventually, when you're trying to generalize the data, right? So some of the things are not necessarily available. Market share, for example, it's easier to collect. It's either the company is traded somewhere with the known stock exchange, or it's a private held, and you have multiple data points or data sources like Crunchbase or even going to the Nasdaq or the Dun and the Bernstein, you got a lot of data points where you can basically create a generalized, well-formatted data point and relate to that. So install base, it's a great feature, but again, you need to collect it in a way that will be, let's call it scalable. But it's a good point. It could be a great feature if you're gonna collect that.
Right, and just to relate to what you're saying, Roy, so because the machine learning, we have a much higher computational ability, it's really nice to add all kind of feature that if we would have to manually analyze the data, we can, use them all. So that's really exciting. And let's go back to our data. So now that we collected, we need to turn it into features, right? Features are the input variables of our model. So if we'll be looking at all this information, some features can be generated, directly from our data. Some could be generated by applying basic algorithms. For example, how often an app is used, or what is the percentage of assets that the app is installed on, and so on and so on. And another method for generating features could be applying machine learning algorithms, kind of a sub-research that for a big model, that their output would be an input for a big model. And by applying the machine learning algorithms, we can predict new information. And a good example for that would be predicting the likelihood of a vulnerability to be exploited if it doesn't have an exploit yet, or when would it be available, the exploit. Another good example could be analyzing CV description and receiving information about the attack or the impact in case of a successful exploit. We can analyze automatically the vulnerability vector and so on and so on. And I believe that, with all these methods, we can generate a diverse feature collection of information about vulnerabilities in 0 days and have include some about the risk, about the usage, about some possible treatments. And we can even add some of the user's taste. For example, which threats did the user choose to treat in the past? And, we might end up with a really high number of features, and that also could be a disadvantage. Why? Because we might be needed to deal with computational cost, with poor performance of our model, or with overfitting training data, meaning that our output function is not generalized enough, and we'll have a high rate of mistakes over new inputs. So what can we do? How can we lower the number of features, but in a smart process? So we can. This is called actually a dimensional reduction.
I thought you were going to call on me again, Shani. I'm glad you didn't.
No worries. Yeah. So there's this method of feature selection, and there's different algorithms that helps us to do it to reduce our dimension. For example, the lasso regression, and what these methods do is help us to select features that are most useful or most informative for our model. And now we get to the most exciting part, where after we collected the data and processed it into input variables, we can finally start training. So if we'll go back to our nice image of the machine learning, right? So what we would like to do here is to choose a supervised learning to solve a classification problem, right? Our problem is, of course, training a function that, using new data, will classify it to a MITRE threat, one of those that we are treating with a patch or patchless protection. And how will we do that? We will want to feed our model with these features that we just collected and selected, and receive a function that when a new data appears will decide whether it is a thread and of which family. Right. So Roy, can you please share us some of the threats our model found?
Yeah, obviously. So, of course, what we're going to show, it's still work in progress, but basically what you see here is a result of such a potential prediction. For instance, we got here one of these techniques we cover through the MITRE ATT&CK framework, where there is a set of properties which you can see and you can really understand, which resulted in a potential exploit for a public-facing application which is communicating with the internet and is out there. So in any case, what we want to achieve, here by applying these models is to take a group of let's call it neurons or features, and with doing these manipulations, we want to result a potential threat where a client can really understand. And let's go again back a bit and understand why it is so important. So I will share again our dashboard. And as you can see here, if you recall, the way that we prioritize vulnerabilities is based on the tags. We are basically tagging data points, and according to that, we apply some risk factors to determine what of the applications are susceptible for an attack or more likely to be hijacked or whatsoever.
And
now,
sorry,
when it
Roy,
comes to,
for our audience especially, and especially those listening, when you're looking at these tags, are those discovered and applied automatically by Vicarious or by Topia, I should say, or is the human applying those, or is it a combination of both?
So these tags are all generated automatically upon deployment of the system. These tags are basically are a result of threat intelligence. So we basically correlate a few feeds. And if there is a matching vulnerability or a matching application that answers some of these feeds, obviously we're going to tag them. So the customer or the client doesn't need to go and to browse through the internet and to try to figure out which of the applications are talked about or in potential, already have been weaponized.
But it's also taking into account the environmental data as well, in terms of, well, if it's Firefox and it has an exploit and you've tagged it with a couple of things, you can say Firefox is the most used application in your environment and blend that together automatically without me having to do anything but put the agent and set this up, right?
Precisely, Paul, precisely. And this is kind of also correlate back to the session where we discussed about the prioritization part, where, every vulnerability got the vector. What we do here is basically we validate that so that the properties of the given vulnerability are being met on the customer side. And upon such, it's something that is more likely or more feasible to be exploited, unlike things that, for instance, require high privileges or some network configuration in order for them to be abused. So definitely it's a good point at which you've raised. We are correlating external feeds and internal feeds. And as I said, looking beyond the horizon, here we got about, I would like to say 20 or 30 tags. In the future, where we're going to have hundreds or thousands of these, again, it will become something that a person will be finding in potential hard to correlate. Because again, clicking here, this is something the system does automatically. For instance, which of my applications are exploitable, in use, and are communicating with the internet. It's very easy to grasp the threat and to take action. But when it comes to a lot of potential tags and a lot of potential threats, it's something that a human may struggle in potential. But of course, again, the fact that we are basically showing the user what are the threats on a nice graph where you can see what exactly contributes to the risk, it's something that we see of high value and high necessity. Because imagine, Paul, if we would have told the client, look, you should trust us because we have like a super sophisticated data, machine learning algorithm which does this calculation. It's very hard in some cases to leverage this in potential, or even get, if you get security teams and IT teams, sometimes because of this dissonance, or they're trying to pull different directions, it's hard to get them engaged and to remediate things. And when all teams see exactly what is out there and how it could be in potential be exploited or hijacked, this is something that we see of great value. So again, here we got only a few of these, and you can see how they contribute to the risk. Imagine again in the future we're going to have hundreds or thousands. This is something that, of course, a model needs to do the prediction. So this is how we are basically trying to harness the power of algorithms and machine learning in order to better predict multiple things. Some of the tags, well, today most of the tags you see here are a result of coding. There is no algorithm who generates that, but like Shani mentioned, there are now work in progress like algorithms who are going to predict, for instance, if something doesn't have an exploit today, but in future it will have, we are now applying some supervised models to create these tags. So it's going to be exciting both on the tags side of things, because some of them will be, again, are generated by humans, meaning a person writes the code, but also others are being generated by machines. Again, whether something will be exploitable in the future, this is one thing. The likelihood for weaponization, which there is already a data set that can represent that, that's another thing. So eventually, if you have the right data, you can also harness this to amazing things, predicting what will be exploited in any given environment. And also another cool feature we are adding is the option to customize. If we revert back to the example of Google Images, where it asks you, hey, Paul, this is a person you say yes or no. So imagine you would personalize the threat also to your company, where the algorithm is going to introduce you, look, Paul, is that a threat you think it's worthy of your time and it's related to, I don't know, data theft or credentials theft, and you're going to say yes or no. So the model going to reprocess the things based on the weights or the inputs you just provided. So as I said, there are exciting things in the field of of data science in connection to vulnerabilities. This is definitely one of the key projects for the company for the upcoming releases.
That's really cool. I have a feature request though. If you want to monitor the dark web chat communications and then funnel that into natural language processing and apply tags based on that, that'd be awesome.
Actually, it already happens. Maybe
does it really?
Not to the full extent.
That wouldn't surprise me. Yeah.
When we process the CV description.
I was going to ask you apply that to the CVE description, right?
Yeah. So this is already being done today. So we process the CV description, and according to that, we can tag a few things. Some of them are more simple, some of them are more complex. But yeah, definitely the CV description is something that we consider, that we definitely use. And all the the advisory links, when you scrape that and you basically process that. So obviously these are things that are of great value to predict potential impact.
Absolutely. Lee.
So I was just wondering about, how about if I, incorporated like checking for my stuff in Showdown to see about vulnerable things like it, or actually I show up at the top of the list?
This is definitely something you can correlate back. This is a data point where not per se will tag that as something it in potential could be introduced to a model. But this is something that we have a lot of data feeds that we collect from, and some of them again are represented here. For instance, the simple ones are: is there an exploit, which it could be, the ones that we know and some that we know less. For example, exploit DB is one example. Mm-hmm. Or Twitter, basically there's the Twitter API you can collect information from, and according to that you can correlate. So Showdown is definitely a feed that in potential could be introduced. We have now quite a lot in our bucket list of feeds we now customers ask us to introduce, so we are working on it. And as we see the tags, the growth is exponential. It's really off the roof. There's a lot of tags which are now on the roadmap. Again, as I said, some of them are coded, and others will be a result of an algorithm generating them.
Do the customers have the ability to input their own private feeds, or set that up so that if it was not a feed that you guys are going to integrate, is there an option to bring in other feeds that are going to be private?
Definitely, there is also it's something we haven't covered that, but there is an API which you can introduce feeds into, and definitely we can generate tags of. Also, getting back to the example of the threat, the threats that we cover. As we said, these are being generated by machine, but we also want to give customer an option to take a few tags and to create his own like threat. For instance, I want you to create a group of all of my applications that are, again, got an exploit, for instance, have been weaponized in the past, are internet facing and running on a sensitive server. So all of that, these tags could result, let's call it a simple threat. What we're trying to also to discuss about is that there will be threats who are going to be compound of maybe tens or maybe hundreds of tags, which again, a human would be finding hard to create. But definitely it's something which is customizable. And some of the tags you see here are things that in potential you would like to adjust, both in the sense of the weights, and now you can really create your own risk model, because company A can say, if there is an expert for me, it's a red flag, it's a no-go. And then I want to weight it far higher than others. Another company would like to say, my sensitive servers, this is the top priority. So I want to tag these vulnerabilities and these assets as something that is more like, more susceptible for an attack or more risky. But again, these are simple models. What we are trying to talk about here is that we're going to introduce something which is a bit more complex and going to collect a lot of data points altogether.
I mean, is it as simple as taking a lot of the guesswork out of your remediation?
Hopefully. Well, we try to make it simple. And the fact we are not using, let's call it, at least for now, we're not using deep learning or neural networks where there is a hidden layer. And then it's very hard to understand what resulted the threat. When you have a model which is compound of multiple layers, which are not necessarily are easy to explain, sometimes you may find it hard to really dig into why it is a problem for me. So as long as we can, we try to keep it simple and try to, at least to some extent, show the different features who contributed for a given threat.
Is there a point where you get too many feeds or bad feeds? I mean, it seems like you could wind up going over the top and actually making negative progress on what you're trying to accomplish.
Yeah, so this is like Shani said, it's the data is all about it. Trying not to collect too many data, things that in potential may damage your model. So definitely, this is something that we need to look up to and to make sure we are not just spamming the model with feeds which don't provide any value.
Roy,
and also,
ahead,
also I want to add to Roy's explanation. It's also okay to add more data that we need, because then we can apply those algorithms of feature selection and reduce the number of data that we use at the end in order to train our model. So it's good to add more data at first and then, smartly reduce it.
I get this. I think this is really awesome. My question is, how do we explain this to some of our other team members and or managers and convince them that this is the vulnerabilities we need to fix first, because it's right here, because it's machine learning and supervised learning, and they're not going to get that right. How do we break it down for them?
Because Shani and Roy said so.
Yeah, I'd buy that.
Yeah, again, the fact that this algorithm is not a black box, and to some extent you can see inside and what contributed to a certain output. Again, for instance, this is a critical vulnerability because of, and let's simplify that. There is an exploit. It has been weaponized. A company like us got breached the other day, and there is a sensitive server. So all of these are data points in the model. Now take that, and you can of course elaborate that, but you have a story here. You can go to your manager and tell them, this is why we need to prioritize this, and that, and not, again, as we discussed a few sessions ago, everything above CVSS 8 is a fix. And then you see there are too many, you say, okay, 9.5, and then try to raise the bar up until you can cope with the numbers.
Right. Yeah, because I think that management really understands when I go to them and say, we're going to look at all of our vulnerabilities, discover them, and anything that's a CVSS score of 7.0 or greater, we're going to fix within 5 business days, right? And they go, yeah, we like everyone feels good. And for a whole host of reasons, that's a really terrible strategy, right? I want to go to management and say, look, we've got a system It takes into more factors than any human can compute in their brains, and looks into that and says, this is really where we need to be focusing our efforts. Is that more of like the conversation that you want to have?
Yeah, precisely. We're trying to divert the conversation, and this is a true story where the board basically fights the chief information security officer about why you didn't patch the 7-zip, and he tries to explain, this is not what's important, really, right, guys. We should be looking somewhere else. When they say, no, this is something which it says critical here. This is a problem. He tried to persuade them. So obviously the discussion needs to be shifted from, something which, again, to a human brain, it's easy to understand, but we need to make it things which are more, make more rational and more making sense to the given company unique risk factors.
Jeff.
I want to pose your question slightly differently. It's essentially what Paul just asked you, but throwing in a PCI question for you. Customers that are subject to PCI, they're allowed to prioritize their vulnerabilities, whether they know it or not, but they're supposed to do it based on a pre-described or predefined risk ranking criteria. So my question is, how can you guys help companies write up their risk ranking criteria, which ultimately will satisfy, I think, board members, to Paul's point, but more importantly, how do you satisfy the assessors and the auditors that come in and say, oh my gosh, there's all these 7.0 findings, why haven't you fixed them? Well, we have this document here that explains in somewhat detail, but also human readable, human understandable. Here's how we're approaching looking at vulnerabilities to determine their risk to our environment. Have you given any thought to that? Beyond what you were describing to Paul.
I'm disappointed. We only get to drink twice because Jeff only said PCI twice. I guess that means I said it anyway. Sorry, continue, Roy.
I think it's a great question, and I will separate my answer to two parts. First of all, I think regulation and PCI, it's the third time, needs to be advancing with technology. For instance, I will give the example of virtual patching, or we call it patches protection. But the virtual patching concept is out there. It exists. It's a thing, and it's not something, at least as far as I know, a box you can tick on your regulation that needs that asks you to patch something in a given period. And obviously there is a difference between what regulation dictates us and where the technology is at. So we hope that in turns the regulation could understand that a company can define its own risk factors, unless they say we don't have any idea how it works, and they can comply with the existing ones as standards requires. But we hope the technology will advance and allow a company to take advantage of new techniques like virtual patching and patches protection or new risk models. That being said, again, we can customize the risk model according to a given company's requirements. So yeah, we bring the tools, we bring you the latest tech, but eventually it's up to you if you're going to use it or not. So you can adjust the weights according to your, something that would be PCI compliant, and do it, by the book. Not necessarily the most relevant to a given company's risk factors, but it will satisfy some regulation. So we can comply with the past or look to the future. There are two options.
That was very prolific, Roy. I like that.
Yeah.
And yet very unsatisfying. Let me restate the question a little bit, because you responded by bringing up patch management, which ironically the patch management requirement in PCI is immediately after the requirement to come up with your own risk ranking criteria. So even the patching within PCI is supposed to be based on risk ranking criteria, which PCI allows you to do. I guess what I'm looking for is less of an automated technology response, but a way to describe it in a document so that somebody can read it, even if it's just got pictures, but can accept the fact that your technology is doing, all sorts of different things. But can you say what that is on a piece of paper in a relatively terse manner, so that humans can, and not necessarily practitioners can absorb it, can consume it.
So
Are you
let's have
saying
a
like
look.
PCI auditors need to have things described in pictures rather than words in the books they read?
I think most people would rather have things described in pictures rather than words. Like, people that are trying to imagine the apparatus that Tyler's attached himself to right now that aren't watching the video. The imagination just goes wild. But the point I'm trying to make is, you're not just having to sell management or the executive suite. You also have to sell the auditors and the assessors that are going to come in and bless this from a compliance perspective.
Yeah. So in terms of explaining why a given vulnerability or a given application or a given thing is something that worthy of your time, this is the best way, at least we came up with, basically explaining you why something requires of your time. So the different factors are easily shown. Unlike, for instance, a full feed of CVEs where you're trying to understand whether something is applicable or not. So the way that we do that, we basically attach different factors, as you can see here. And of course, it's all things you can generate and show the auditor, look, there is an exploit here, and therefore it's something that is worthy of our time, or it's a new vulnerability, people are tweeting about it, there are predicted threats here, and this is why we need to take an action. Unlike things which are in low risk and in potential may not necessarily needed to be applied. So this is kind of how we can illustrate an auditor what or why something is worthy of his time. And again, keep in mind, these weights are something which are adjustable. So a given company can define their own weights, their own criteria, and adjust the risk factors according to their own security policy. So getting back to your question, how can you justify an auditor whether something is actually at risk, even though, or not at risk, even though there is a high or critical vulnerability? We are using the tags mechanism in order to achieve that, and I hope it answers your question.
The old way is flawed because it doesn't take into account all of those data points. This way does. I think if you could also provide, if it were me, I would provide the auditor with documentation on, here's the methodology we use, and here's how we've tuned it to our environment to derive, these particular scores or priorities that we're taking action on, Jeff, right? So maybe it's not necessarily like Roy and Vicarious's responsibility to do that. But if I were the customer and you were the auditor, if we could take on those roles, I would say, here's our methodology for adjusting the priorities and severities of the vulnerabilities that we face. Here's how we've kind of tuned and modified the model, and here's why.
Well, I want to add to that. Sorry.
Go ahead.
I want to just add
ahead.
to that not only the apps, we have this risk explanation, but also in the machine learning model that we showed earlier, all those threats that the model identified, it's not a black box. For each threat that was identified, there's some of the features that the model used in order to decide that is a threat. Roy, can you share with us that screen again, please?
Sure. And there we go.
No, not that screen, the live threat screen, please.
Yeah, that one's basically your results, right?
Yeah, so even here, it's not a black box. We want the security team to understand why is that a threat, and to retrain the model if they believe that's not a threat, or it's not a threat that they want to treat. So it's not a deep learning model where everything is unknown and we can understand what happened. It's a model where it is understandable, and the features that were used in order to decide that it's a threat, or at least some of them, are presented here.
So, I want to give my little marketing pitch to you guys. Paul, they're not obligated to explain it. It's a sales opportunity. There are over 5,000 companies that are listed on the Visa Global Service Provider listing. Service providers always have to do the full PCI DSS, and then even the larger enterprise size merchants is also probably in the pushing 10,000 companies in North America right now. You guys are offering a way for companies to tailor their risk ranking. Everybody else that we've talked to, that I've talked to, that is tackling this, prioritization thing this year has their own way of rolling it that they push out. And what I've asked each one of them is, how do you let the customers choose? How do you let the customers set the thresholds, set the variables, set the criteria? And they all kind of fumble over that. You don't. You have an immediate response. So nudge, nudge, wink, wink. There's a huge market out there for people that would love to do this, because vulnerability remediation is the bane of most companies that have to do PCI. Just like everybody else, they hate having to go through the hundreds and thousands of vulnerabilities. Give them a way to cut down to what's real and what's most relevant. You will have a customer for life. I'll rest there.
No, Jeff, I think it's sound advice, and I think that the ability to do that and have insight into that process is huge. It's huge, because as we've already shown on previous episodes with Shani and Roy, it can be highly subjective, right? And we've also shown that one particular public data point, like a CVSS score, is also flawed in so many ways. All that kind of leads up to, I think, what Roy and Shani showed us tonight, was that this can all be seemingly automated. I don't know if that's the right word, right? But this data can be aggregated by software rather than humans to help us make better decisions, is really what we're after. I mean, compliance may one thing, but ultimately, in my opinion, this helps us make better decisions.
Would agree.
Sweet. Questions, comments from anyone else? Roy, is this a newer feature that you're rolling out? Is that?
Yeah, this is will be rolled out in the future release, and we are now Michael is going to have a session about the upcoming feature. Will not still is thunder, but definitely we're going to introduce a lot more models and a lot more machine-driven insights and threats in the near future. So definitely stay tuned.
I was curious.
Go ahead, Tyler.
Around your subscription or pricing model. Like how does and maybe you've covered this on a previous episode, but how does your kind of structure work from a purchasing side?
It's per asset, basically, because what we're trying to do here is to bridge the gap between the scanning, finding the issues, make the decision, and fixing them. So it's all per asset, per node, you can call it. And this is how it's being priced. Basically, any device we're going to provide you value for.
And your current platform support?
So we support Windows, Linux, and Mac.
Oh, so you support Linux now too?
Yeah, we got the full coverage. Also for the cool features like the patches.
So, you lived up to your word. You said you would have that for the end of the year. That's awesome.
Want to ruin them all.
I'm excited.
Yeah.
Yeah.
That's great. Well, Roy and Shani, thank you so much for appearing on Paul Security Weekly this evening.
Thanks,
it's been a pleasure
for having us. It's been a pleasure. Thanks.
Always nice having you both. For folks that want to learn more, make sure you visit securityweekly.com/vicarious. Coming up next, Harry Sverdlov from Zscaler. Stick around.